Hi everybody, welcome back to the section 4.4 video. And in this video, we're going to take a look at another example of a non-homogeneous differential equation and solving it by the method of undetermined coefficients. So we have here our homogeneous part, and we have on the right-hand side our non-homogeneous part. Okay, and this non-homogeneous part gives us our particular solution, and our homogeneous component gives us our complement solution. So we need to get both of these components. And like the previous examples, it's always easier to figure out what the complementary component is. It's just a lot quicker and a lot easier to get it over with. So let's go ahead and start our solution. So let's write solution, and we'll look at step one, and that's getting our complementary solution. So solve the complementary solution using the auxiliary equation, and that's from section 4.3. Okay, so our homogeneous component, I'll say HOM for homogeneous, is going to be y double prime minus 8y prime plus 20y and equals 0. That's our homogeneous component. So we want to build this auxiliary equation based on the standard form of a constant coefficient homogeneous equation, which is, ay double prime plus by prime plus cy equals 0. Okay, so our components here are a equals 1, b equals -8, and c equals 20. So when we build up our quadratic characteristic equation, it will be m squared minus 8m plus 20 equals 0. Okay, 8 and 20, this actually is not factorable. It's not factorable. So what we would need to do is use our good old friend, the quadratic formula. So we would need to have the quadratic formula. We would say m equals negative, you know, 8, excuse me, negative 8 plus or minus the square root of -8 squared minus 4 times 1 times 20 all over 2 times 1. So not factorable. Use quadratic formula. Okay, and just for reference, if you don't remember the quadratic formula, it's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Just in case that's not engraved in your mind from your youth. Okay, so, this is algebra, this quadratic formula, and so kind of skipping some of that steps, you can do it off to the side if you would like. But what this dwindled down to is 4 plus or minus 2i. Okay, so that is our root from our auxiliary equation. So these are complex roots. And when we have complex roots, 4 is our alpha, and the number attached to the imaginary I is our beta. Okay, and a solution to complex roots is y equals e to the alpha x times c1 cosine of beta x plus c2 times sine of beta x. So that means our solution here would be e to the 4x times c1 cosine of 2x plus c2 sine of 2x. And so that's our complementary solution. Okay, so complex roots give us this complementary solution. Now is the time to get going on our particular solution. So step 2 is form a trial particular solution. So our non-homogeneous component is this 100x squared minus 26x e to the x. Okay, that's our non-homogeneous component that's going to give us our particular solution trial setup. So let's go ahead and rewrite that down here. We'll say f of x equals 100x squared minus 26x e to the x. So we have a lot of moving parts for this trial particular solution. We have a quadratic up front, and then we have a x e to the x, okay? So a trial particular solution would look something like this. It'd be y sub p equals, taking care of that quadratic first, would be ax squared plus bx plus c. That would be the first component. So let me put like parentheses here to make sure like that's for sure from the 100x squared. Okay, and then the next component would be plus dx plus e because of that 26x, and then we would just leave e to the x times that linear function. Okay, just because we have that x times the e to the x, we need to take care of that as a linear function. Okay, so that's our setup. And so what could we do now? So what I want to do is, I guess for the derivative sake, I want to distribute in this e to the x. So let's go ahead and distribute this in. And let's drop the parentheses. So ax squared plus bx plus c plus dx e to the x plus e to the x. So strange having e to the x, but we have to work with it or choose a different letter, but we'll just stick with it. And now what we want to do is start taking some derivatives. And so the first derivative is 2ax plus b. C is a constant, so derivative of a constant is 0. And here's where we have to be careful with dx e to the x, because this is going to require a product rule. Right? It's f times g prime plus g times f prime. And, we'll say f, f is dx, g is e to the x, so f prime is just d, and g prime is itself e to the x. So the derivative would be dx e to the x plus d e to the x. And the derivative of e to the x is just going to be itself. So this is these two terms right here are branching off of the product rule. Okay, we need to take another derivative. What would that look like? This would be 2a. And then we would have another product rule. And so what that would become is plus dx e to the x again, plus d e to the x, plus another d e to the x, plus e to the x. And these are the product of that, or these are the terms from the product rule. Okay, so almost there. We can clean up a bit. We have two d e to the x's here. We could add those up and we can get 2a plus dx e to the x plus 2d e to the x plus e to the x. Okay, so be careful. We don't want to try to combine these because they have different coefficients with the d and e. Remember, we're trying to solve d and e, so we don't want to eliminate any possible coefficients. So we have our derivatives. Took us quite a bit of work because we had a product rule we had to worry about. But let's go ahead and start plugging these into the differential equation and start solving for all these coefficients. So we have A, B, C, D, and E. We got a couple to solve for, but it's definitely doable. So let's go ahead and get started. So step 3, plug in particular, prime, and double prime into the differential equation and solve for A, B, C, D, and E. Okay, so our differential equation, just to rewrite it from up above, is going to be y double prime minus 8y prime plus 20y equals 100x squared minus 26x e to the x. Okay, and so when I start solving for this, we got to insert our particular, our first derivative, and the second derivative. So let's go ahead and plug those in. So what I would get is 2a plus dx e to the x plus 2d e to the x plus e to the x minus 8 times 2ax plus b plus dx e to the x plus d to the x plus to the x plus 20 times ax squared plus bx plus c plus dx to the x plus to the x, and this all equals 100x squared minus 26x e to the x. Okay, so that's our very long setup. Let me zoom out a little bit. That is our very long setup. So what we need to do now is sort of clean this up. We need to distribute in the -8 and 20, and we want to drop some parentheses and then start to see what cancels out or what combines together. So let's go ahead and get started on that. So let's distribute in the -8 into all of these terms and then the 20 into all of those terms. So when we do that, let's also drop the parentheses. But what we get is 2a plus dx e to the x plus 2d e to the x plus e to the x. All right, then we would get minus 16ax minus 8b minus 8dx e to the x minus 8d e to the x minus 8e e to the x. Okay, now moving on to our next expression is to be 20ax squared plus 20bx plus 20c plus 20dx e to the x plus 20e e to the x. And this all equals 100x squared minus 26x e to the x. Okay, so let me zoom out so that we can have all this on the screen. Okay, so what we want to do now is start to see if anything combines with another like term. So 2a, I don't see another just single a term, but I do see that we have a couple dx e to the x's. So this is dx e to the x. We have another one right here, -8d e to the x. And then we have a 20 dx e to the x term here. So we would add those together. What else? What other like terms do we have? We have a couple, or I think just about two d e to the x's. So we have one here. I'll make two lines for that. And then, excuse me, I've underlined the wrong one. It's right here. For dx e to the x. This is our second d e to the x. Okay, and what else do we have? We have a e to the x. We have a couple of those terms. So I'll triple underline now those ones. E to the x, e to the x, and e to the x. Okay, so let's go ahead and add those terms with their respective like terms. And so what we get on the next line is 2a plus, it would be 13 dx e to the x minus 6d e to the x plus 13 e to the x minus 16ax minus 8b plus 20ax squared plus 20bx plus 20c equals, excuse me, equal 100x squared minus 26x e to the x. Okay, so we what we typically do now is we want to be able to equate coefficients. So what we want to do is rearrange these terms to look like our right-hand side so that we can equate coefficients cleanly. So I'm going to reorder a couple terms and shift some of these terms around. So here I'll say, you know, rearrange terms. And what we get is, or the way I would do it is 20ax squared minus 16ax plus 20bx plus 2a minus 8b plus 20c plus 13, looks like a b, plus 13 dx e to the x minus 6d e to the x plus 13, looks like a b again, e to the x equals 100x squared. And so this is where we rearrange terms to look like the right side, because this right side would be 100x squared, but I'm missing like the zero, missing like the x and the constant. So it would be like 100x squared plus 0x plus 0 minus 26x e to the x. And then it looks like I'm missing a 0 e to the x term because of this e to the x terms right here. Okay, so need to have a 0 e to the x placeholder. And so a lot of work to get here, but now what we're going to do is equate coefficients. Okay, we're going to equate coefficients now. So we're almost at the home stretch. We're going to be able to solve all of our constants that we're looking for. And this one is a bit of a domino effect because the first equation I can equate 20ax squared, I can equate that to 100x squared. So 20x squared equals 100x squared. I'm equating the coefficients, so this is just like 20a equals 100. So then a just equals 5. Okay, let's look at our second equation now. It's negative 16ax plus 20bx equals just 0x. And so I can factor out the x, and I can just equate their coefficients. So negative 16a plus 20b equals 0. And I know what a is. Just plug that in right here. And what I get is negative 16 times 5 plus 20b equals 0. So this would be negative 80 plus 20b equals 0. And so b would actually end up being 4. Okay, so we have a and b. Let's move on to our third equation now, which is just the constants. So just these constants right here. So what this would end up being is our third equation. We have 2a minus 8b plus 20c equals just 0. Okay. And I know what A and I know what B are already. So this ends up being 2 times 5 minus 8 times 4 plus 20C equals 0. And so this ends up being negative 22 plus 20C equals 0. So C ends up being 11 over 10. Okay, so like I was saying, this is a bit of a domino effect. And so we're moving steadily along getting our coefficients. So let's move on to our fourth equation. Our fourth equation is stemming from our 13 dx e to the x. Okay, so on the right-hand side, it equates to this negative 26 x e to the x. So let's go ahead and write that. It would be 13 dx e to the x equals negative 26x e to the x. So we're equating coefficients, right? Both of these terms have x e to the x, so this would just be 13d equals negative 26. And so divide by 13, we get d equals negative 2. All right, our last equation, equation 5, would pertain to just the exponential constant term. So it would be just this negative 6d e to the x and 13e e to the x, and it would relate to just this e to the x 0 placeholder. So we would get negative 6 d e to the x plus 13 e to the x equals 0 e to the x. So let's go ahead and factor out an e to the x just to make the equating a bit cleaner to see. Okay, so we can now equate the coefficients. 6d plus 13e equals 0. I know what d is. We can plug in d right here. Negative 6 times d, so negative 6 times negative 2 plus 13e equals 0. So 12 plus 13e equals 0. And so e would equal negative 12 over 13. Okay, so we got all of our coefficients that we need. We got A, B, C, D, and E. So it was a bit of a domino effect, which works out cleanly for us. And we are almost done. We just now need to finish our particular solution and then wrap them up to our general solution. So here we'll say step 4, plug A, B, C, D, and E into the particular solution. So what was our particular solution again? Let's scroll up to see it. It was, I'm gonna use the original one right here. So ax squared plus bx plus c plus parentheses dx plus e to the times e to the x. And I'm going to plug in my a, b, c, d, and e now. And so my particular solution would be 5x squared plus 4x plus 11 over 10 plus negative 2x minus 12 over 13 times e to the x. Okay, so that's my particular solution. So that's not my final answer. My final answer is going to be the general solution. So general solution now, and recall a general solution is the complementary times the particular. So my general solution is going to be my complementary, which we got all the way back up in step one, is going to be this solution right here. Okay, so let's take that, rewrite it down here. E to the 4x times C1 cosine of 4x plus C2 sine of 2x plus 5x squared, my complementary, plus 4x plus 11 over 10 plus negative 2x minus 12 over 13 e to the x. And that's my very long solution. Okay, so this was a very long problem, very long. So hopefully you're able to stick through it. And when you try these problems on your own, make sure to stay focused and make sure you're doing your little things correctly because it is a long process sometimes. All right. But other than that, thank you for watching. A couple more examples to do and watch, but I'll see you guys all in the next video. Okay, take care.